All right, let's look at this question here. It says 6 d2y by dx squared minus dy by dx minus 40y equal 22 times e to the 3x. What are we going to do? To do this question, as you can clearly see, 6 d2y by dx squared minus dy by dx minus 40y equal 22e to the x. First thing we start by, we need to solve 6. I'm going to skip a step. I'm just going to write down the auxiliary equation for this part. The auxiliary equation is going to be 6. I'm going to change it up from u to use m today. 6m squared minus m minus 40 equals 0. That's our auxiliary equation. Then after we write down this, we solve our auxiliary equation. And I'm really lazy. I am really lazy. Can't bother to solve that one right there. So what I'm going to do is I'm gonna use this calculator right here and solve it. Really can't bother 6. I'm gonna just use quadratic formula and solve it. It's minus b, so it's minus 1, which is 1, plus or minus, plus the square root of b squared, which is 1 square, minus 4a, 4 times a, where a is 6, times c, which is negative 40. This is being divided by 2 times a, c, 8 over 3. So that's one possibility. M equal 8 over 3. What's going on? I don't know why that didn't erase. Let's go again. Let's get off that. M equal 8 over 3 is one possibility. M equal 8 over 3. That's one possibility. Or let's look at the next possibility now. Let's look at the next possibility now. So to get the next possibility now, what we need to do is go back in this calculator right here and change this to a minus. So we're going to change this to a minus and see what we do get. So let's change this to a minus and see what we get. Minus 5 over 2. So that's the next possibility for m, minus 5 over 2. So that's it. Of course, we could have factorized it, but I just couldn't bother. So now we're going to write down our complementary function. So the complementary function that we are getting is, our complementary function is y is equal to a, some constant a, times e to the 8 over 3 times x. This don't look like 3, try to fix that. Plus some another constant b times e to the 5 over 2 times x. That's going to be our complementary function. Nice. Whenever the roots are real and equal, it takes this form. All right, nice. And so what we're required to do now is, let's go ahead and find our particular integral. Now, since this is 22e to the 3x, our particular integral will take the form of e to the 3x times something, we can call it k. So first we need to write out this again, 6 Let's go ahead and find our particular integral. So we have 6y prime prime, and that was minus y prime minus 40y. This is minus y prime minus 40y equal to, that was 22e raised to the 3x. What does that mean for us? That means for us, or particular integral, let's call that yp. Yp is equal to some constant. I'm going to use q. I don't want to use p. I'm going to use q e to the 3x. That's the form our particular integral will take. And so when the particular integral is in this form, then all we have to do now is yp, find yp prime, which is going to be 3q e to the 3x, and then yp prime prime is going to be equal to 9q e to the 3x. Easy, soft. So since this is what we're going to get now, we're going to group all three of these and plug it into the original equation. So this is going to become, now 6 times y prime prime, which is 6 times 9q times e to the 3x, which will be something, minus y prime, so it's minus 3q times e to the 3x, and then it's going to be now minus 40 times y, which is minus 40 times q e to the 3x, and that is equal to 22 e to the 3x. It's equal to 22 e to the 3x. Nice. So since this is what we have now, all we have to do now is just expand this and see what we get. 6 times 9 is 54. So what we get is 54 q e to the 3x. Why didn't I just do it one time? Minus 3q e to the 3x minus 3q e to the 3x. And then we have minus 40q minus 40q e to the 3x. And so that, and we know this is equal to 22 e to the 3x. So now what I am going to do is, I don't like to simplify it and write it as one thing. I like to divide through by e to the 3x. All right, that's just what I like to do. I like to divide through by e to the 3x. You don't have to follow me. You can just simplify it there. I like to divide through by e to the 3x. I like dividing through stuff to get 54q minus 3q. Then that is minus 40q minus 40q, and that is equal to 22. So then now I know 54q minus 3q is 51. And then 51 minus 40 is 11q. And then 11q is equal to 22. And so q is equal to 2. That is q. Q equal 2. Now that q is equal to 2, this is not bad. Now that we're getting q equal to 2, then we have our particular solution. Our particular solution, yp, is equal to 2 times e to the 3x. That's our particular solution. Yp is equal to 2 times e to the 3x. That's it. So now we can write our general solution. Beautiful. So of course, again, we know that our general solution, I'm just going to write GS for general solution. General solution is the complementary function plus the particular integral. Nice. So writing that out, the general solution y is equal to the complementary function up here, which is a times e to the 8/3 x plus b times e to the 5/2 x. Then we need to add our particular integral now, plus particular integral, which was, I think that was what, 2e to the 3x? Yes, 2e to the 3x. And this is the general solution. 2, oh my god, backspace 3 times, 2e to the 3x. That's it. That's our general solution. Soft, 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 a capital T. Soft. Yep, soft. That's what we get. Nice.